All right, so last video here for our test review, we're going to look at the normal distribution here. Final scenario says current IQ tests are normally distributed with a mean of 100 and a standard deviation of 15. Answer the questions below. Make sure to sketch a distribution and write a probability statement where appropriate. So A says, what is the probability that a randomly selected person has an IQ of 140 or below? So with a normal distribution, I really only have two choices that we've discussed so far. I can use normal CDF. I can use inverse norm. I don't have a percentage on this one, so I'm not going to use inverse norm. I'm going to use normal CDF. So what I'm looking at is a bell-shaped curve. It's symmetric. It's unimodal. In the middle, I've got my mean of 100. It's given to me right here. I'm looking specifically at the mark of 140 and below that. So I'm looking, well, what area of the curve is this? What percentage, what probability do I have? So this will come from normal CDF. Lower bound, upper bound, mean standard deviation. So this goes all the way down the curve. You can say, well, the lowest IQ is 0, is your lower bound. For consistency, anytime I go down the lower side, I'm going to use negative E99. Normal curve is a theoretical distribution here. My upper bound when my shading stops is 140. My mean is 100, and my standard deviation is 15 from right here. So to get to that normal CDF, we'll go second vars. It's number 2, never normal PDF for this class. So I'll go with negative second comma to get that E, my 99, comma 140, comma 100, comma 15. So we get 0.9962. So a lot of the curve was shaded would be 99.62% as a percentage. We're just asked for the probability, so I'll leave it in that decimal form. Same idea in B. Probably that the IQ is above 90. Here, this will be 100 in the middle. I'm looking a little bit below that now at 90, and I'm looking at 90 above that region. So this will be another normal CDF. Lower bound is 90. I'm going all the way up the curve. I'm not sure what the highest IQ score is, so I'll go E99. Still a mean of 100 and a standard deviation of 15. Second vars, number 2. So 90, comma, and then to get my E99 again, that second comma, there's my E99, comma 100, comma 15. So we get not quite as much of the curve, 0.7475, or about 74.75%. See our last normal CDF question here. So still bell-shaped curve, plenty of room in the tails out here. 100 is in the middle. I'm looking between 95 and 125, so 95 down here, 125 here. Looking between, so no E99. So I've got my lower bound, my upper bound given to me. Be normal CDF, 95, 125, 115. Second vars, number 2, 95. And we get 0.5827. Moving to D, what IQ score corresponds to the 75th percentile? Oh, I'm sorry. Before I move to that one, I forgot to write the probability statements above. Here for A, we're looking below 140. So this is probably that X, your random variable, is below or less than 140. B is probably that X is greater than 90 because we're looking above 90. And on C, Probably that X is in between 95 and 125. So I'd say 95 less than X less than 125. So my X is between those. Now on to D. So what IQ score corresponds to the 75th percentile of IQ scores? This is an inverse norm question. If you're at the 75th percentile, that means you are above 75% of scores, but you're below 25% of scores. So you're somewhere up here. So you've got 75% of people below you, only 25% of people above you. You want to know what value of this? So we use the inverse norm function because of these percentages that we have. 0.75, 100, 15. You use your left-hand percentage as a decimal, then your mean and standard deviation. So second bar is for those distributions. Inverse norm is number 3, as you can see. So 0.75, comma, 100, comma, 15. So getting about a 110. If your IQ is a 110, 75% of people below you, 25% of people above you. Same idea on E. What IQ score separates the lowest 40% from the top 60%? So when I make my sketch, 100's in the middle. I'm going to be somewhere down here. So I've got 40% on the low side and 60% on the upper side. If I do it right at 100, you've got a 50-50 split in that case. So I'd move it down. So I've got 40 on the left, 60 on the right. So this would be inverse norm. 0.40, 100, and 15. .2 or just a flat 96 there. On F, Edward has a Z-score or has an IQ of 125. What is a Z-score and what does this mean? You'll get the Z-score formula in the test. Z is equal to X minus mu over sigma. Mu is your mean, sigma is your standard deviation. X is your given value, so it would be 125 minus 100 divided by 15. I'm looking at 25 divided by 15. So gives me 1.67. So this means that Edward's IQ is 1.67 standard deviations above the mean. Remember, when your Z-score is positive, it's above the mean. When your Z-score is negative, it's below the mean. 125 is definitely above the mean. It's above the mean by 1.67 standard deviation. And final question on the review to get ready for the test. What IQ scores would be classified as unusual? So to be classified as unusual in the normal distribution, you have to be 2 or more standard deviations from the mean. So on my normal curve, my bell-shaped curve, we'd have 100 in the middle. One standard deviation above will be 115 because the standard deviation was 15. So 2 standard deviations will be 130. So 130 and above would be classified as unusually high. But there are also unusually low scores. So if you go down by 15 once, you're at 85. The second time, you're at 70. So then 70 and below. All right. So use these questions as a guide of what to expect your test to look like for test 2. Some multiple choice questions, some short answer questions. Email me if you have any questions.